All right, let's talk about the domain of a function. Well, first of all, what is a function? Remember, a function is a relation in which every element of the domain, which is usually your x values, corresponds to exactly one element of the range, which again is normally your y values. Now, you can depict a relation, and specifically a function, in several different ways. First of all, we may have some ordered pairs. So I wrote out 4 ordered pairs. Notice -3, 2, 0, 1, 1, 1, and 2, 4 are my ordered pairs. Now, the domain is going to represent your x values. So the domain of this ordered pair are the x values here. So the domain is the set of numbers -3, 0, 1, and 2. Of course, the y values would represent the range. All right, now we're familiar with ordered pairs. You may not be familiar with mappings. With a mapping, you have all of your x's, which again are your domain, that's in one oval, and they're going to correspond to y values, which represent your range. So like when I write -3, 2, -3 is an x value, it's going to correspond to the y value of 2. 0, 1. 0 is part of my domain. It's going to correspond to the number 1. 1, 1. 1 is in my domain. Now it corresponds to the number 1. I already have a 1 written. So I just draw my arrow back up to that 1. And then 2, 4. 2 is part of the domain. It's going to correspond to the number 4. Now you can also write this function as points on a table. We can have an XY table or T-chart. Notice your X's are all the values in your domain, and your Y's are all your values in your range. So we can write the ordered pair -3, 2, 0, 1, 1, 1, and 2, 4. And then we can also depict this function as a graph. We can graph the ordered pairs -3, 2. So we go left 3, up 2, 0, 1, we just go up 1, 1, 1, and 2, 4. And recall that when you see the picture of a function, it passes the vertical line test. If you draw a vertical line anywhere through your graph, the most times it would hit the graph would be 1 time. Okay, so this relation is a function. And again, the domain of this is -3, 0, 1, and 2. All right, now the problem is that we're not always given ordered pairs or a mapping or a table or a graph that looks like that. Sometimes we're given an equation. So it's better for us to look at that equation to determine the domain. Again, the domain are your x values. So the first example, we have y equals 3x plus 1. We notice this is a line. It has a y-intercept at 1 and a slope of 3. If I think to myself, are there any restrictions on my x's? Is there any value that I cannot put in place of x? No, there's no restrictions. Notice this line goes forever to the left and it goes forever to the right. So the domain of this function is going to be all real numbers. So the domain, when I say all real numbers, that means I go from -infinity, that's where the graph begins, goes all the way to +infinity. So I'm going to write it in interval notation. It goes from -infinity to +infinity. And you always use parentheses when you're using infinity or -infinity. Okay, the next example is y equals the square root of x minus 1. Again, you always read a graph from left to right. You think, where does the graph begin and where does it end? Notice this graph begins when x is at 0. Then it goes forever to the right to infinity. So when we write our domain, we're going to write it starts at 0, and since 0 is an included value, we're going to use a bracket. and it goes forever to the right to infinity. The next one we have, this is called a rational function, y equals 4 divided by the quantity of x minus 2. Notice on this, there is a restriction. There's no value when x is at 2. There's actually something called a vertical asymptote right here. So the graph never does touch x equals 2. It's an imaginary boundary line. So our graph is going to begin at negative infinity, and it's going to go all the way up to that 2, but it doesn't include the 2. And then it picks back up again at 2, not included, and goes to infinity. So our domain, we would say, goes from negative infinity up to the 2. And again, 2 is not part of the solution, so we're going to use parentheses. And then we're going to connect these answers together. We're going to use a union symbol, looks like a U. Then again, it picks up at the 2, and it goes to infinity to the right. Now, you may say, well, how would you know that this x equals 2 is this vertical asymptote? When you have equations that have a variable in the denominator, think about, you can't ever have 0 as a denominator. So what would make this fraction undefined? It's going to be undefined when the denominator, x minus 2, equals 0. And if you solve that, you see x equals 2. This is where the graph is undefined. You cannot put a 2 in this problem. That's what causes this vertical asymptote, so it will not be part of the domain. So these are two examples of what you really have to watch for when you're looking at domain of a function. If you have an even root radical, so a square root, a fourth root, a sixth root, that's what you've got to watch out for. Or if you have a fraction in the denominator, or excuse me, a variable in the denominator, of a fraction. So you can have an odd root radical, there's no restrictions. As long as your variable is not in the denominator, there'd be no restrictions. But these are the two you have to watch out for. Okay, usually the domain is from negative infinity to infinity. Usually. Okay? All right, that's it.